This is a section from the second book of the Arthur Koestler trilogy, The Act of Creation. A section called Gravity and the Holy Ghost on page 124 in my copy. Quote, "If I have been able to see farther than others," said Newton, "it was because I stood on the shoulders of giants." End quote. One of the giants was Johannes Kepler, whose 3 laws of planetary motion provided the foundation on which the Newtonian universe was built. They were the first natural laws in the modern sense, precise, verifiable statements expressed in mathematical terms. At the same time, they represent the first attempt at a synthesis of astronomy and physics which, during the preceding 2,000 years, had developed on separate lines. Astronomy before Kepler had been a purely descriptive geometry of the skies. The motion of stars and planets had been represented by the device of epicycles and eccentrics, an imaginary clockwork of circles turning on circles turning on circles. Copernicus, for instance, had used 48 wheels to represent the motion of the 5 known planets around the sun. These wheels were purely fictitious, and meant as such they enabled astronomers to make more or less precise predictions, but above all they satisfied the dogma that all heavenly motion must be uniform and in perfect circles. Though the planets moved neither uniformly nor in perfect circles, the imaginary cogwheels did, and thereby saved the appearances. Kepler's discoveries put an end to this state of affairs. He reconciled astronomy with physics and substituted for the fictitious clockwork a universe of material bodies not unlike the Earth, freely floating and turning in space, moved by forces acting on them. His most important book bears the provocative title, A New Astronomy Based on Causation or Physics of the Sky, 1609. It contains the first and second of Kepler's 3 laws. The first says that the planets move around the sun not in circles but in elliptic orbits, and the second says that a planet moves in its orbit not at uniform speed but at a speed that varies according to its position, and is defined by a simple and beautiful law. The line connecting planet and sun sweeps over equal areas in equal times. The third law establishes an equally elegant mathematical correlation between the length of a planet's year and its mean distance from the sun. Kepler did not start his career as an astronomer, but as a student of theology at the Lutheran University of Tübingen. Yet already as a student he was attracted by the Copernican idea of a sun-centered universe. Now canon, Copernicus's book on the revolutions of the heavenly spheres had been published in the year of his death, 1543, that is 50 years before Kepler first heard of him. And during that half-century it had attracted very little attention. One of the reasons was its supreme unreadability, which made it into an all-time worst seller. Its first edition of 1,000 copies was never sold out. Kepler was the first continental astronomer to embrace the Copernican theory. His Mysterium Cosmographicum, published in 1597, 54 years after Copernicus's death, started the great controversy. And Galileo entered into the scene 15 years later. The reason why the idea of a sun-centered universe appealed to Kepler was repeatedly stated by himself. Quote, "I often defended the opinions of Copernicus in the disputations of the candidates, and I composed a careful disputation on the first motion which consists in the rotation of the earth. Then I was adding to this the motion of the earth around the sun for physical or, if you prefer, metaphysical reasons." End quote. I have emphasized the last words because they contain the leitmotif of Kepler's quest, and because he used the same expression in various passages in his works. Now, what were those physical, or if you prefer, metaphysical reasons which made Kepler prefer to put the sun in the center of the universe instead of the earth? My ceaseless search concerned primarily three bodies, namely the number, size, and motion of the planets, why they are just as they are and not otherwise arranged. I was encouraged in my daring inquiry by that beautiful analogy between the stationary objects, namely the sun, the fixed stars, and the space between them, with God the Father, the Son, and the Holy Ghost. I shall pursue this analogy in my future cosmographical work. 25 years later, when he was over 50, Kepler repeated his credo. It is by no means permissible to treat this analogy as an empty comparison. It must be considered by its Platonic form and archetypal quality as one of the primary causes. He believed in this to the end of his life. Yet gradually the analogy underwent a significant change. The sun in the middle of the moving stars, himself at rest and yet the source of motion, carries the image of God, the Father and Creator. He distributes his motive force through a medium which contains the moving bodies, even as the Father creates through the Holy Ghost. Thus the moving bodies, that is, the planets, are now brought into the analogy. The Holy Ghost no longer merely fills the space between the motionless sun and the motionless fixed stars. It has become an active force, a vis motrix, which drives the planets. Nobody before Kepler had postulated or even suspected the existence of a physical force acting between the sun and the planets. Astronomy was not concerned with physical forces, nor with the causes of the heavenly motions, merely with their description. The passages which I have just quoted are the first intimation of the forthcoming marriage between physics and astronomy. The act of betrothal, as it were. By looking at the sky, not through the eyes of the geometrician only, but of the physicist concerned with natural causes, he hit upon a question which nobody had asked before. The question was, quote, why do the planets closer to the sun move faster than those which are far away? What is the mathematical relation between a planet's distance from the sun and the length of its year? This section goes on, but I shall pause right here.